Section 7.4, Day 1, Properties of Logarithms. Essential question. How do I use properties to simplify log expressions? Who uses this? Seismologists use properties of logarithms to calculate the energy released by earthquakes. Remember that to multiply powers with the same base, you add the exponents. So b to the m times b to the n is equal to b to the m plus n. The product property of logarithms. The logarithm of a product is equal to the sum of the logarithms of its factors. So the log base b of m times n is equal to the log base b of m plus the log base b of n. This property can be used in reverse to write a sum of logarithms exponents as a single logarithm, which can often be simplified. All right, so let's extend the page. And here's a helpful hint. You never leave log in your final answer unless the directions say to write the equation in logarithmic form. Then yes, you're going to have log in your final answer. You must simplify all other problems that end with the answer in logarithmic form. So if we have a log j plus a log a plus a log m, that is equivalent to the log of j times a times n. Example number 1. Express log base 6 of 4 plus log base 6 of 9 as a single logarithm. Well, like back here, we just said in this property, if I can get there, the sum of two logs is equivalent to the product of m times n. So that's what we're going to do. So we're going to rewrite that as log, a marker here, log base 6. We're going to take 4 times 9 and set that equal to x. We have a log equation. To simplify a log equation, we change it to exponential. So 6 to the x power equals 36. 6 to what power results in 36? The answer is x equals 2. Example 2. Express as a single log. All right. $625 times 25. Set it equal to x. Change to exponential. 5 to what power is 156? 15,625. That's x equals 6. Oops. All right, the next one. Expressed as a single log. You have a log plus a log. We can change that to the log with the base of 1/3 and the product, 27 times 1 over 9. Set equal to x. Change to exponential. 1/3 to the x equals 3. Remember what we said when we have 1 over something, that means our exponent has to be negative. So in this case, x is -1. Remember that to divide powers with the same base, you subtract their exponents. Because logarithms are exponents, subtracting logarithms with the same base is the same as finding the logarithms of the quotient with that base. So here's an example. If we take the log base 5 of 16 over 2, that's the log base 5 of 16 minus the log base 5 of 2. Logarithms must have the same base in order to be simplified. That is critical here. All right, express log base 5 of 100 minus log base 5 of 4 as a single log. We're subtracting the same base. 100 divided by 4 is 25. Change to exponential. 5 to what power is 25? X is equal to 2. An example 4. Log base 7, and you're subtracting, so we take 49 divided by 7. Change to exponential. 7 to what power equals 7? X is equal to 1. Because you can multiply logarithms, you can also take powers of logarithms. The power property of logarithms states that if we have log base b of a to the p, we can rewrite that and we can bring the p in front. P times log base b of a. So let's do an example. Express as a product, simplify if possible. So we have this power up here, so we're going to bring it in front. So that's 2 to what power equals 32. Put this as an equals x. 2 to what power is 32. And 2 to what power gives us 32? 2 to the 5th. The answer's 30. Next one. Right? Use the power property. We're bringing the 4 in front. Oops. Let's try that again. X. All right. So we have 10 to what power equals 10? Ten to what power equals 10? That's 1. Example 6. Express as a product. Simplify as possible. Same thing as example 5. Bring the 2 in front. Five to what power is 25? And here, 5 in front. Two to what power is 1/2? Well, we did a reciprocal, 1 over. So we know that then the x value is going to be negative. Express as a single logarithm, simplify if possible. Expressed as a single logarithm, simplify if possible.